All right, hi everyone. Now we're gonna do the backwards reaction for this primary amine reaction. And the reverse reaction is pretty tricky, but I feel like if you know the components of the forward reaction, then I feel like it's easier to start the backwards reaction. So I'm gonna refer to the last video. This is my work from the last video, where we started with the carbonyl here. Then we formed our hemiaminol, we formed our hot electrophile, and then we ended with our final product. So since I split my reaction up in this way, I feel like it's easier to go backwards. So we're starting with our imine, and now we're trying to form our hot electrophile. Then we're going to form our hemiaminol, and then we're going to end with our carbonyl. So that's the kind of the terminology that I'm going to use as we go backwards, and I feel like it's easier to think about it this way than think of the PAD or DAP method if you're familiar with that. So that's how I'm going to do it. So first we're trying to form our hot electrophile, and in order to do that, our nitrogen's lone pair is going to grab onto a hydrogen in our solution. The solution is still acidic, so the hydrogen can really come from anywhere. We have our hydrogen that's now on the nitrogen, our CH3 that's still there, and now this nitrogen is positively charged. And the reason why this is now a hot electrophile is because of the huge dipole moment between the carbon and the positively charged nitrogen, plus the dipole between this carbon and the nitrogen. And hydrogen isn't really electronegative at all, so we're mostly focusing on these dipole moments. But since this carbon is such an excellent electrophile, it's a hot electrophile, it really wants to do science. So now our water in our solution is going to come in, attack the carbonyl carbon, or the amine carbon, I guess, and then it'll make this double bond break and give a lone pair back to the nitrogen. And after we form the hot electrophile, which we just did, now we're trying to get to our hemiaminol step. So we're on our way there. We have our water that just added, and we have our NHCH3. And now we see that our nitrogen is happy because it has 3 bonds and 1 lone pair, but our oxygen is unhappy because it has 3 bonds and 1 lone pair. So we want to make our oxygen happy, and we can do that by having something in our solution, probably water, take a hydrogen off of this oxygen, and then we're going to form our hemiaminol. So we have our OH, and then NHCH3, and this is our hemiaminol. We're almost done. So since we know that we're trying to form a carbonyl, we already have the oxygen that we need, that's right there, but now we have to try to get rid of this whole nitrogen group, our original nucleophile in the forward reaction. So similar to how in the forward reaction, we wanted to give our OH a reason to leave. In the backwards reaction, we want to give our nitrogen a reason to leave. And the way that we're going to do that is the same way, where we're going to have one of the lone pairs in the nitrogen grab onto a hydrogen in our solution. It could be water, it could be really anything. So once it grabs onto a hydrogen, our nitrogen will be positively charged because it has 4 bonds, and our OH is still happy. So now this nitrogen has a reason to leave. It's positively charged, it's totally unhappy. So our OH is going to fold over, form this double bond, and kick off all of this nitrogen crap. So now we have our carbonyl, but it's positively charged. And the part that just fell off is the CH3 and H2. And we know that it's a CH3 and H2 because we have 2 hydrogens and a CH3 right here. And we're just reflecting that right here. I don't think you really have to write that down, but if it makes you feel better, then by all means go ahead. So now that we want our carbonyl to be happy, we're going to have something in our solution, grab onto our hydrogen. And now we're going to form our final product, which is the carbonyl. So I'm going to go back to the forwards reaction because I put these notes in the same place, and I'm going to show some similarities between the reactions, and I feel like this will make everything make a little bit more sense. So we started with our imine right here, and then we formed our hot electrophile, we formed our hemiaminol, and then we got to the end at our carbonyl. And if we think about going in the forward reaction, I'm going to move a little bit up. When we went in the forward direction, we had our carbonyl, and then we formed our hemi, the hot electrophile, and then an imine. And I'm going to go back down here. So if we think about doing this reaction forwards, using our backwards work, we can see that at the hemiaminol state right here, when we're going backwards, we protonated the nitrogen because we wanted the nitrogen to leave. But let's think about if we were going forwards. Let's think about if we're going in the forwards direction. So if we wanted our nitrogen to stay and our oxygen to leave, then we would protonate the oxygen. So since what our work in front of us is showing is that we're going backwards, if we wanted to go forwards, then we'd be drawing an arrow this way. And if I wanted my nitrogen to stay and my oxygen to leave, then I would protonate my oxygen, just like how this oxygen is protonated and it's unhappy. So at the hemiaminal state, whether you're going forwards or backwards, you will always protonate something. Here, since we're going backwards, we protonated the nitrogen because we wanted to form our carbonyl. We wanted to keep our oxygen there. But if we're trying to form an imine, then we want to get rid of our oxygen, so we protonated the oxygen instead. And I feel like this hemiaminal step is so important because it really lets you know where you need to go. If you're going backwards, then you know you're trying to form the carbonyl. You want your nitrogen to leave. But if we're going in the forwards direction, then we want to get rid of the oxygen so that we can form our CN double bond. So I hope this video helped, and let me know if you have any questions.